Good morning, everyone. Thank you for joining us today with our webinar, Unleashing the Power of JSON, XML, and Web Services and RPG with Modern DevOps. We're thrilled that you're all here. My name is Kirk Francis. I'm the North America Sales and Marketing Representative for Remain Software, and I'll be here to guide you through this session and help you gain some valuable insights that we can enhance your development practices. So we have today two incredible experts with us. First, let me welcome Niels Liisberg. Can you wave your hand?
Hello.
There's on camera. He's the innovator behind noxDB and IceBreak. Niels will be sharing his expertise on leveraging JSON and XML and RPG programming. And then joining him is Jongman from Remain Software. Wim, give us a hand. There we go.
Hi.
He'll be just demonstrating how to implement DevOps best practices while creating web services from your RPG programs. Before we dive in, let us get to know each other a little bit. If everyone can join in on the chat and share where you're from today, so you can get an idea where everybody is from. And let's put on the chat. So is everybody able to get into the chat? There we go. Omaha, Nebraska. We've got New Jersey, Sweden, Grand Rapids, Michigan, Scotland, Louisiana, Indiana, Reedsville, Liverpool, Portugal, Italy. So we've hit Europe. Oh, we've hit South America. There we go. Peru, the UK, Vero Beach, New York, South Africa. I think we hit all continents, but maybe Australia. Wow. Anybody from Australia?
I think it's time to say good morning, good evening, and good night.
Yeah, good morning, good evening, good night. All right, so one more question just to kind of get a pulse of everybody. Please indicate what your primary interest is on this webinar. We're covering multiple topics, and I wanted to see if you're interested more in JSON or XML transformation, please respond with JSON or XML. If you're more interested in primary interest is web services, please respond with a WS. And if one of your primary interests is DevOps practices, please respond with DevOps. So we'll give a moment. Looks like JSON is a big one here. Web services as well, DevOps. Okay, so there we go. Quite a bit of interest in all of our topics. That's good to see. So feel free to as well to enter in other if you have a different focus in mind, or just type it in. And then regarding questions, please feel free to ask questions during the demo. We'll do our best to address them later. We have a very tight time schedule, exactly 1 hour for this demonstration. And what we will do is we'll go over maybe a little bit to address the questions. If people want to stick around, we understand everybody's scheduled for the 1 hour, but we'll go over the questions after that 1 hour. So stick around if you're looking for that. We will make the recording available to you as soon as it's done. So thanks everyone so much for sharing your input. I'm hopeful that Wim and Niels may also do this a little bit throughout the webinar to get some feedback from everyone. So without any further delays, let's get started with Wim and Niels. Thank you.
Thank you, Kirk. Hello, Niels.
Hello, everybody. Hello, Wim and Kirk. So good to see you guys.
Yes, wonderful. So I'm feeling really excited to do this demo, and I'm also very happy, Niels, that we have the honor that you are here because you are the main man behind noxDB, and that is basically the service program that we are going to demonstrate today, and then we are going to touch on all kinds of little parts. So welcome, Niels.
Thank you so much for having me. So great to be here.
Okay, so what we're going to do today is just a little introduction about Wim and Remain Software, then Niels and System and Method, which are our respective companies. Then we're going to refresh up really quick about JSON. What is JSON, right? I must assume that everybody knows what JSON is, but just a quick reminder about how this relates to RPG. And then we're going to talk about noxDB, which is the service program that we use to parse and create JSON and also XML. So then I'm going to show a simple noxDB program. I'm going to program it with our DevOps tool, so you have a little feel of that. And by the way, keep in mind that our DevOps tool is also completely powered by noxDB. So for all the JSON in out, what you see is all noxDB behind there. Then I'm going to give the floor to Niels, and Niels is going to dive deeper into noxDB, telling you a little bit about all its secrets. And then Niels is going to show how he is using noxDB in IceBreak, which is a very effective HTTP server. Do I say that correctly like that, Niels?
Yeah, absolutely.
Okay, brilliant. And
perfect,
then and then after that, Niels is also going to show you how to get noxDB, how to install it on your IBM I. So a lot of information. And then later on, we have created some programs, and I'm going to push these programs to test with our DevOps tool. And then, yeah, we're done, and we have some, we can address some use cases and Q&A. So let's get started. So first, a little bit about me. My name is Wim Jongman. I am the CTO of Remain Software. We're a Dutch company. I'm a Dutch guy. I'm living in Haarlem, in the Netherlands. Some of the icons you can see on the left. I have 4 kids and 1 wife. People often ask me, okay, how you have so many kids? Did you get remarried? No, I didn't. And then I'm also a nerd, right? Because I like nerdy things like you know, computers, programming, 3D printing, electronics, astrophotography, the universe in particular. So anything that is, you know, yeah, I don't know, has to do with nerdy things, you can count me in, and we can chat about all those things. Our software consists of TDOMS, which is our flagship product, and it's a full stack DevOps product going from initial inquiry, for example, hey, my customer maintenance program is broken, and the whole cycle from development, testing, peer review, and deployment back to production is taken care of by that product. We have a couple of other products, notably iUnit, which is open source. Maybe you want to take a look at that. A very lightweight a unit testing system to give you a good appetite of how effective testing is. But yeah, we have other tools as well. If you're interested, you can take a look at that. But because we have a little time, or we have an hour, but we want to put a lot of in there, I'm going to keep it with this. So Niels.
Hello, everybody.
Your turn.
Niels Liisberg here from Copenhagen. I'm a chief architect at System Method and also a member of the CX. So if you have any good ideas for the platform, please post it to me or go to the ideas, and I will certainly look at your ideas and see if we can put that into the schedule for IBM. But my main work is actually I'm developing and in this area of transformation and modernization, doing tooling around that on the IBM I platform. And our best practice for that is we have an application server called IceBreak that is kind of filling the gap, so you can run cloud native applications directly on the IBM I, like Spring Boot, Fast API, and so on. But also bringing our ILE universe into the loop. So when we're talking about IceBreak, it's actually I started up for like 20 years ago. A guy called John Paris asked me if we were interested in perhaps an open these applications into open source area. So if you're looking at the right side, you will see that there is some open source, the noxDB, iElastic, and iElevator. And these are actually open source packages. And because we are a tiny company here in Denmark, we are only 15 people here in Copenhagen, 5 people in Brazil, and 5 people in Kathmandu. So we're not a huge company, but we achieve a lot by using open source and invite people to work with these products as well. So IceBreak actually was our enterprise solution for making web serving and application serving for ILE universe. And then we brought the microservices, Spring Boot and Flask loop back on board, so we can spin up Node.js applications together with the ILE universe. And it works as a coherent application stack for transforming your business. But today we will look at the noxDB. So that is actually just carved out of the IceBreak and make an open source. And it's actually available on GitHub. And I will show you in a moment how we can just download this guy and install it and build it from scratch. So you can also participate in this project. But this is how open source works. It's a kind of freebie in the bar, you know. You can have it, but we always expect that you're giving something back. This is how open source works. So in this case, you can see all the red stuff, and this is noxDB. And this is the reason why we built it, because we saw that when we are using HTTP, there's a lot of technology going on in the HTTP stack that is not interesting for the ILE developer. So when I saw Internet Information Server for many years ago, I was very excited about that they could plug in DCOM and COM object directly in the server architecture and serve application like that. Say, wow, that is a good idea. Where can I buy that on the IBM I? And that was not possible. So we made this solution where we have the HTTP stack, and then we need to pass the JSON and bring that into the green area where your code actually exists. And when you're done with all your magic in your code, you also have to serialize it out and back to the client. And noxDB is doing exactly that. And we have a concept of JSON in and JSON out. And this is actually what is going on here. So you will not see the JSON in your code. You will only have this framework of noxDB doing all the magic. And one of the side effects is also that we want to extrapolate on what we can do with the database. So also noxDB has an interface for doing IOs directly with SQL. And that means you have the complete stack of IOs, serialization and parsing directly on your fingertips with the noxDB framework. So the rest we will show you in a moment how that actually works. So Wim, perhaps you will talk a little bit about what JSON is.
Yes, I will do that. I first have a question for you. How do you get these cool names like IceBreak and noxDB? Is there a little story behind those?
Of course, IceBreak was actually because we were at that time 50% Windows guys and 50% AS400 guys. Mm-hmm. And I wanted to break the ice between these two different mindsets. So we made an icebreaker, and therefore the name actually just, it came out of the breaking the ice of how people are thinking. So we have a common, so therefore we have a common language with the JSON stuff. At that time it was more XML, but anyways, the young guys came on board and worked with IceBreak, even though there was Windows guys, and also the other way around. People from the AS400, at that time it was called that, came on and worked with it was called ASP at that time. So therefore it was called IceBreak. And noxDB was also, it's a little outdated word because it actually stands for not only XML. So it came out of the time where we have not only SQL, so no SQL and not XML is actually acronyms in this world. So it's not only XML. It does all the tricks. Yeah.
It does all the tricks. Yeah. Wonderful. Yeah. Great names. Okay, thanks, Niels. So let's dive in and take a look at what is JSON. What you see actually here in the title is a valid JSON notation, and I will tell you a little bit more about it. But first, what is JSON? Well, JSON is a lot. There's a big Wikipedia page around it, but from our point of view, what we use it for is the favorite communication format of the internet. So when you go in a browser and you press the developer tools and you investigate, you will see that all the data is actually transported in JSON. So it is transported in JSON from the web application to the server. The server receives it, parses it, makes new JSON and sends it back to the app, and the app then translates that JSON again. So JSON is really the glue of the internet. So if we want to translate that to RPG developers, let's do it like this. So we have this presentation data structure in RPG. We have 4 fields, presenter 1, presenter 2, presenter 3, and count. And the equivalent JSON for this is this. So it starts with a curly bracket, it ends with a curly bracket, and then we have a field with the field name, the value, comma, field value, comma, and then finally the last field. And JSON and RPG data structures, they map really well, right? It's really easy to explain JSON by using a RPG data structure. So let's take another one where I have an array, right? So an array of presenters of char 10, dim 10, so it means 10 array elements in this case. You would fill it like this, and in JSON, it would be represented like this. The array actually starts with an open bracket and ends with a square bracket open and square bracket closed. That denotes an array. And in this case, presenters is an array of primitives, an array of strings, and comma count 3 again. So Niels, you mentioned about the dimension, the dimension of an array in the data structure while not having any dimension in JSON.
Yeah, that's correct. And that's also a thing we are looking at when we are looking at the noxDB in a moment. You will see that when we are making arrays or making objects, we don't have the penalty of having to decide the sizes of data. I know you can, in RPG, you can say dimension star auto and all this stuff, but you still are limited into the memory you have in your RPG programs. And you also have to declare the sizes of your character and the sizes of your numeric fields. So this is one of the things we want to mitigate with the noxDB, to get rid of declaration of sizes. But we'll come back to that in a moment.
Yeah, it is already a property of JSON that string size can be any size. Yeah, okay, so that is one of the differences. So let's take a look at nested data structures, where you have a data structure in a data structure. So for example, we have an address qualified data structure with first name, last name. We have our presentation data structure again with presenters like DS address, dim10, and now we have a data structure inside the data structure. We would fill it like this, and inside JSON it would be something like this. So again, we have the presenters array because we start with an open with a square bracket and we end with a square bracket, and inside are again JSON objects. They each have a curly opening and closing bracket. Okay, so this is an array of JSON objects. And again, we have the count field. But let's go to the star of the show of today, and that is noxDB. Okay, so what is that? So let me explain to you how we can get those data structures and work with them with noxDB inside RPG. So if we want to get this JSON structure, what we want to do inside RPG is we want to do some boilerplate code, right? So we have a binding directory, noxDB. We get the prototypes through this QRPGLE ref member, and we are declaring a pointer. So a pointer is kind of the bad boy in RPG, right? So it does not maybe have a good reputation. We are, as RPG programmers, not really used to working with it. But in other languages, especially in the more low-level languages, it is very common. So a pointer actually is an area of memory that you can use to put anything in. So it's basically a free format data structure. And Niels is going to tell you a little bit more about that, but this is what noxDB is using. So then we use this procedure that we get from the service program. Hey, make a new JSON object for me. and use this pointer for it. So what will happen, you see this in red, it will create a graph, an internal representation of the JSON object, and Niels will tell you later more about that. Then we can add a field to that JSON, for example, presenter1, presenter2, presenter3. And this is how it gets filled inside the JSON. So we have methods like setString, setInteger, right? So these are all the methods that come with noxDB, all the procedures that come with noxDB. Then we have this JSON and we want to do something with it. For example, we want to write it to a stream file, or we want to, whatever you want to do with it, right? Or you want to send it back to the web application. But we do something with the JSON, in this case, write it. Then an important thing that you have to do with every pointer is to deallocate the pointer. In this case, we use JSON delete, very important. I've been bitten by it. And then we can terminate the program in the old-fashioned way by setting on in LR, last record indicator. Okay, so this is a basic part. So let's take a look at the other examples where we are creating an array. So again, we have some boilerplate code. Now we add a new JSON object, a new pointer called names. And inside that, we make a new JSON array. That is also a procedure. The pointer is a names, and then we can array push into names the individual presenters. We can set int the count again, do something with the JSON, and then, move object into, that's an important step. We take the main JSON and we say the arrays are going to be moved in the field presenters, and you get exactly what you see over here. And then write it to stream file, delete it again, and exit the program. Last one is where we have this array of JSON objects. So to give you an example here, is where we are pushing inside the names array a parsed JSON string, right? There's many other ways to do it. You can already maybe feel your fingers tingling by, hey, I want to try this out. But there's many methods over here inside the JSON library that makes your life really easy. And this is one way of how we would populate a JSON like that. Again, we move the object into the JSON, and then we write the stream file and we get out of here. So let's see that into practice. What I'm going to do, I'm not going to compile that whole program, but so this is actually in here. So I have my website, but let's go into VS Code. So inside VS Code, I have TDOMS running. We can see my tasks over here. So I'm working with the master JSON with noxDB task. And if I click on it, it tells me what objects are attached to that task, right? I have already attached some JSON objects to it. What I'm going to do is I'm going to open this JSON file, and what happens now is that I have included this this program, right? So let's go over it again. So the binding directory, the prototypes, declare the pointer, create a new object, and then we are going to set the values and write it to a stream file. And that stream file actually is this one, right? So we can take a look at that stream file later on. Okay, so if I now run it and so let me just first save that. So I'm saving it. TDOMS says, okay, great. You want to build that. So it adds that object automatically to the build queue. So let me release that build queue. And of course, after a second, everything is fine. Should I make an error in my source, of course, then the build queue will put the object in. So every time you save, basically your object will be recompiled. And it will tell you what is wrong when something happens. And then I can, for example, show the errors in the source. And it will tell me that this indicator is not defined. Okay, very nice. Thank you. And recompile that thing again. Okay, let me get rid of all these messages. So I have this program in this library called simple, and I can go to my IBM I. Let me see, where am I? Yes, I'm in the correct location. Call from this library, simple, and it's done, right? So one of the things that we will see later on is the absolute light speed of this JSON transformation. It's just unbelievably fast, orders of magnitude faster than any, let's say, JDBC connection that you have to make if you hit the iron directly. Okay, let's go in and find my output. That's over here. And you can see this JSON file is very nicely formatted. So later on, after Niels is done, I will take all these programs and promote them through the development cycle. But for now, I'm done with this part, and I'm going to ask Niels to show some advanced noxDB and IceBreak stuff.
Absolutely. So I will just start sharing my screen here. So I think we will have a blank desktop. Can you see I have a blank desktop?
Yes, I can see it.
All right. So what I will do here is actually drill down from a running application so you can see how it works. So I will, whatever I'm showing here is actually run on top of the IceBreak server. So I'm logging into something that's running 100% native. So this is an IceBreak application. And this particularly application I want to show you is how we are creating this application here. So basically, in old days, we would call this as a classical subfile. One thing that you can do with IceBreak is actually you can spin up a 5250 screen. Yes, it is 5250 with a little bells and whistles. But anyways, you can create new applications in ILE and have this noxDB up and running. So if I just go backwards from this application and see how it's done, you can see we have some search information. We'll play with that manager. You can see I can search in the database and everything is fantastic. Order by the values and so on. How can I create an application like that with noxDB? So I'll just log out here and then I will go back and show you my my examples here. So I have a little repo out on the internet on GitHub. I will just open it up. If you are searching on Liisberg GitHub and click on my Git repository, you can see there's the IceBreak samples down here. This is the exact samples I'm using for this little showcase here. And if you want to play with it, you can actually just clone it and get it up and running. So in this example, I'm using IceBreak, but it can also be using CGI or Elastic or any other type of web server. So I will just extrapolate a little bit on your example where we have this hello world.
Yes, so, great.
So you already showed that you have an output pointer, and then you're creating an object into that one. So now I have an object and I will start populate some key values into that. Key will be text and I will say hello world. I will put a date in there. You can see we also have set date and set time. And then I will use set string. And look at the little thing here. I'm putting a text in the message where I'm getting something from the JSON object. And when we're talking about JSON object, noxDB has no concept of JSON. It has a concept of a graph under the covers. So when we are looking at JSON, it will actually pass the JSON under the covers and put this information into a tree structure of data. You know, tree structure is pretty much like a directory where you have directory with a folder, and in this folder you can have other folders, and in folders you can have files. So this is a kind of this tree structure you're used to if you're opening the Windows Explorer, what you're doing here. So this is just a very fast memory version of the data. And it only occupies as much data as you put into it. So when I'm creating this string here with hello world, it will only occupy this, 20 bytes of memory in the node of the object graph. So therefore, it's very small when you're actually creating this. So in this case, I will use a built-in build system that it comes with IceBreak. So I simply press Control B for build, and it will bring up the build task in IceBreak. And so when I compile this, I can compile it directly from my IFS. There's a better way to do it, and this is where TDMOS is coming in, where you can use a real DevOps system to make the build process going. But this is just for the examples of the IceBreak environment here. So now I have made an hello world. So I can actually take this URL here. If I copy this guy here and open a browser and say, paste this guy in here, you will see it very fast gets the information. My name is John, and put that into the message. So this is the basics of how you are creating these JSON objects going in and out of it. So we'll just go back to the example we had before. The application you saw just before is based on this this product application here, where we have some get rows. So yeah, I have a decent endpoint here. And this is where the magic really begins, because now I'm pulling some parameters out. I'm pulling the search parameter you remembered before. I'm pulling that out from my JSON object and put it into a variable. So now it's just a simple variable in my application. And then I am having a basic SQL statement, select everything from this ICE product. I'm adding some where clauses and so on, but that's not important. The important part is I'm having a select statement, and I put that into a parameter of the SQL result set. And when it goes to SQL, it actually runs the SQL query and populates the result set back in the graph. So it actually pulls out the information, and now it's in the graph. I can just return that. So this is the concept of the JSON in and JSON out. So I have my input is JSON in the graph, and I returned it as JSON from the graph. So when I compile this little baby here, I will also just do this, boom, and I have created this. So now I can take the just call the endpoint. So when I'm taking this URL and put that into, so I need a browser where I killed my browser. I put it in here. You can see that actually I'm just going to the application I just compiled with a speed of light. Actually, if we're looking at the speed.
Niels, can you show us the here?
Yeah. Yeah, you were jumping the gun. I was jumping the gun. I will just show you how fast it actually is. When I click on this guy here, you will see that it takes like 22 milliseconds to do a round trip here, where the 17 milliseconds is the rendering and downloading. And this is because I'm doing this on my iPhone, actually, this presentation here. So it has to go over the iPhone, yeah. But anyways, you can see here we have the store that is actually the get rows. And in this example, I'm just mimicking it will do a post. So when I'm making a get with a payload, it will be the same as a post. So if you want to see the final application up and running, I can just remove everything here, because in this particularly Git repo, I also provided a little client. So now you'll see it loads the client. And when I clear this guy here and say I want to look at Sony product, poof, you can see the router is called, and in 30 milliseconds I have the response back. So you can see this very, very fast.
It takes longer to load the PNG than to get the data.
Absolutely. And you will also notice that because it's actually using a paging technology, so you will see it calls the router in 3 times here for getting all the pages are available. So therefore, it's very, very powerful. So let's get back to the examples once again. I think we are okay in time here. So I will just get rid of this guy here. So when we are looking,
you guys are okay on time.
Yep. So you can see that was actually the way we get the rows. So when I'm making a REST endpoint, you will also notice that we have this concept of a router calling it. This is how we make microservice. So the microservice is doing the parsing of the JSON and creating the object graph. And then it actually calls the MS product, that is a service program. If we look at the top of this guy, you can see this is a service program, and it's actually exporting everything, and it has a no main and binding to the noxDB, just as Wim was explaining to you. So this is a very, very simple way to produce an endpoint. The only thing you have to do is to say, I want to export it. And if you export it, it will be available for the client to access. If you are not saying export, it will be a local procedure in your RPG code that is not exported. So if I go back to the simple version here, I can very easily make a hello Wim endpoint. When I save this and compile it, then you can see now I have this guy compiled. So if I try to call the original endpoint, it should not be available any longer, because you cannot find the hello any longer. But if I change the endpoint to hello Wim, there you go. So this is the way you can just copy your endpoints, and you can just very easily modify the endpoint's name. I'll just go back to this, so I will not pull this with the strange stuff. And there's another concept when we are talking about microservices together with noxDB. If you have a division, for instance, if you divide something by 0, it actually fails. So if I run this guy here, I need to compile it here. Compile this guy here. Boom, there you go. And if I take this particularly division, I also have to change this a little here. So there you go. If I take this URL and paste that into my browser, you will see I can divide something with 10. That's fine. If I then divide it with 0, then it actually fails, because you cannot divide anything by 0. So what happens here, you can see that it actually makes an exception. MCH 1211, attempt made to divide by 0 for a fixed point operation. This is not going to happen. So notice it actually says success false. And if you're looking at the code, it's actually not handling. So under the covers, you have here exception handling that will also send back the JSON object explaining the error that actually occurred in your stack. And this is a way that you have graceful error handling in a microservice and service architecture nowadays. So if we're just looking at the application once again, if you're looking at the MS product, that was my base application. We have the get rows, I just showed you that, but it also have the other features. For instance, if we're looking at the sorting, it's simply taking the sort parameter out of the parameter that is given in the graph, and adding the order by. And here we have some issues with injection, but this is only for example. So don't do this at home.
Don't do this at home. Yeah.
So typically I will have a string quote around this, so it will actually encapsulate any injections. So, but in this case, I'm not doing injection checks. But the more important thing is when I'm adding the where clause, because that is also using another little trick in noxDB. It's doing two things. First, it gets some metadata from the SQL. So when you say select star or splash from a table, it actually provides you with some meta information, what columns and what type of data is there. So when it brings back the JSON object to you, it also have a meta tag that can tell you what kind of data I'm supposed to look at. Especially here, the names are good. So all the columns I have in my select states, and I can do an iterator. An iterator simply is a managed loop you can simply do with noxDB. So it creates an iterator, and it has a function that is saying for each of, and that's all the elements that is in the array or in the object. So if it's an object, it will take all the key values and give you back as an iterator. If the array, it will take all the array elements and give you back. And then you can see it actually appends the name is actually taking the name out of the metadata. So this is actually the current version of the iterator value. So this is another very, very nice feature in the noxDB. So when you're handling arrays, it's as easy as having a for each, and then you can do whatever you have, and that could be writing whatever. In this case, I'm just making a little string appending for the search keywords. Then we have a little update, and the update is done by an upsert. And this is a little crazy word because it actually takes a JSON object in, and it maps the names of the JSON, the object graph key values, and find these particularly column in the database table you are trying to update. And if the row exists, it will update it. If it does not exist, it will insert. So therefore, the insert update is actually an upsert. I tried to post that as an idea for IBM. They declined it.
Okay. So upsert is update if it's there, and insert if it's not there.
Exactly. So therefore, it's this is the way we're doing this particularly application, where we just have one upsert for doing both insert and update. The ensure key is not interesting, but it actually finds in this particular. It's a little fun because in this case, this table don't have an automatically incrementation of the primary key. So what I'm doing here is I'm taking a result row because I don't need a result set. I simply just take one row, and in this case, I take the maximum value of the product key, and then I add 10 to it. And this will be my next key. So I have steps in 10 for automatic generated keys in this. And then I can copy a value from one object to another. So JSON copy value is another feature that's built into it.
Yeah, you go really deep now, Niels.
Yeah, I know. Yes.
So you're way down in the puddle. I think
yes.
We're going to lose you.
Yeah, don't get me started, as I said.
Yeah,
but,
okay.
You invited me to talk about all the greedy stuff. Yeah.
Yeah. So the noxDB, how do we get it?
Yeah. Let me just show you how to install the noxDB. If we are going to the noxDB, you're going to see here we say go to GitHub and just say noxDB. It's not that common name, so you will see it actually pops up as one of the first one. First of all, you will see that it's actually quite huge. The installation process is right here, and I will also go through that very, very quick. So what I need to do is SSH into my IBM I. So I bring up a terminal here. Hope you can see it. So I will just.
Can you grow it a little bit?
Yes, I will grow it a little bit. Here you go.
Yeah, wonderful.
So I will SSH into my IBM I. That's it. And my IBM I is called my IBM I. So now it's connected to my development test environment. And then I need to create a directory called projects. I already done that. But I will have to go into this particularly subfolder directory. And then a directory, and then I will simply clone this guy here. And before you can clone it, you have to yum install Git, and you have to yum install gmake. It's actually in the description here, but I'll just do it real quick. So now it will start cloning it, and while we're doing this, I will bring take over to you.
Okay,
Wim,
thank
so
you.
You can talk a little, yes, because it takes a little time to clone.
Yeah, so this takes a little time.
So
in the meantime, what I'm going to do is I'm going to deploy the programs that we just wrote, the MS product, the MS simple, and all the little examples. That is DevOps deployment time, right? So now we made some programs, and how are we going to distribute those to the development lifecycle? So with TDOMS, we are back inside VS Code. You can see that this task contains a number of components. So we have all the little the programs here. Just before I continue moving this to test, I just want to build everything real quick. So I say add this task to the build queue. So all the objects of this task are added to the build queue, and I can release it. And then TDOM has a smart compile, obviously. First the physicals, then the logicals, first the modules, then the service programs, and finally the programs. But if the programs are to be compiled, we do them in parallel, right? There's no need to compile each program sequentially. We just tell the IBM I, okay, I need all your resources, compile all those 200 programs in one go. So everything compiles fine. I'm happy with this. So now I can go ahead and promote this. So I can do that by doing transfer and promote. But I'm going to show you another really nice way of promoting, and that is using the Kanban board. So you can see here a list representation of all the tasks. These are all my tasks, but I can say, okay, show me the tasks of all programmers, right? So that there's a lot of them. So only my task is great. But to deploy, I can actually open my Kanban boards inside VS Code. And let's give it a little bit of room here. Make this a little bit smaller, or I can actually hide it over here, right? And also hide the bottom panel. This is a not so well-known feature in VS Code, but yeah, once you find these buttons, you cannot live without them. So here we have all our tasks belonging to MS3, milestone 3. So a bunch of things to do, bunch of things currently in dev. And here we have our master JSON with noxDB. And yeah, I can now drag and drop it and put it into test. So what happens here? TDOMS will take the task and put that all the objects that are attached to the task through the pipeline and put it inside the test environment. And within a couple of seconds, let me just refresh it. You can now see that my task is in test. If I want to work on it again, I can drag it to int, to dev again, or if I want, I can drag it to integration. And if you can drag it to integration depends a little bit on, yeah, did we get all the signatures? Was peer review done? So there's a number of yeah, things that needs to be done before you can actually close it out. And also one thing that we take care of, so we cannot directly make it to done, right? Says sorry, yeah, that's not, the target production is not valid. You have to go through int first, right? So it really makes sure that you follow all the lanes in the Kanban. But it has been deployed. If I go back to my list and press refresh here, you can see the status is now test, and the testers has been notified so that they can start doing their testing. Okay, back to you, Niels.
Yeah, while you have been talking, I have just finished the cloning process. So now Git has actually placed everything on my IFS. So I can go into this the folder in product folder, and it's called CD and noxDB. And if you're looking at what's in here, you can see we have a make file and we have some source code. So basically, when you have cloned the project, you can simply say gmake. And gmake is another thing you have to yum install, but it's when you have it, it's basically just firing away all the normal commands you will do for compiled programs and objects. So you can also put that gmake into TDOMS for if you want to build noxDB yourself. So now we have the JSON XML service program, and it's placed in a library called noxDB. So now we are ready to real play with it. So if I go into the noxDB, I have mapped a drive to this particular space. Then you can see we have all kind of interesting examples. So if I go to, let's just take to the very first one, the basic features. Yes, exactly. So you can see that this is basically what you already have shown, creating an object and putting strings, integers, numbers, dates, timestamps, and booleans into it. But that's something you should notice when you are making your own application. If you come from a CSID from 536, I can't remember it, but you know this where the CSID is not set on your system. You have to explicitly tell noxDB what CSID is in your source files. And noxDB is shipped with the examples in CSID 500 as international. So you can do this if you don't know what the CSID is, and if you are sure that you have set your CSID on your system and you are aligned with the CSIDs on your source physical files or your stream files, then you are good to go. Then it will be converted correctly. But this is always a good idea to say, set the delimiters.
Explicitly set it.
Yeah.
Yeah.
And then there's another feature. If you're using some of your testing environment, iUnit, for instance, there is a little courtesy function here that will enable all your unit test calls. So you can actually have your own procedures called, and that will be part of the iUnit if you want to do so. So setting the tracing information, and what it does is actually each time you are interacting with the graph, getting or setting or changing or whatever you do, it will call this particularly procedure and say you are changing this, you are deleting this, and you are creating this object and so on. So the trace information is quite immense, but it's very good if in development environment.
Yes.
So when you are finished with it and put it in production, you should do something like this, or have a definer around it, whatever.
Yeah, exactly. So we put generally this in a separate method, and then inside the method we say, in the log method we say if debug off, and then also in production, if we need to, we can switch on the debug flag, and then have the information also outputted in production, which can be very valuable. So we actually keep it inside the program. Yeah, wonderful feature.
Yeah, and one of the good things, if you're looking at this particularly vanilla installation of what we are using here is of VS Code. It doesn't use the code for I in this case. But if you are using code for I instances, then you will notice that all the mouse over function actually works. Thanks to Liam has adopted this notion of how the prototype are described in the prototype file. So it's the same syntax we're using as in VS Code.
Yeah, we use the same.
Sorry, not VS
ILE
Code.
docs.
The ILE doc, exactly. So therefore, when you have mouse over and you want to look at outlines and so on, it actually explains very nicely what parameters are required and what types of data is, thanks to Liam. Actually, I think Liam is on the list here, and Liam has also been very helpful by bringing this to Git and making the documentation of noxDB. So thanks, mate.
Yeah.
Where you are.
All right, so that is on sitemule.com.
Yeah.
If
you are going back to this particularly noxDB, there is further reading. That's a little power wire here. That was not what I want to show you. It was the documentation website here. If you're clicking on this one, you will see we have examples also how you install it. noxDB, git clone it, gmake and all this stuff, and how you're using yum. It uses git and gmake. And you also have the parsing files, how it actually is done. You can parse JSON, you can parse XML, but it basically just puts it into the object graph. So when it's in graph, it has no idea where it's come from. Looping through arrays here, you see the iterator stuff. So the documentation is very good on this, both for the JSON and the XML APIs. So you can see there's a lot of prototypes, a lot of features you can actually interact with the object graph with this one. So actually, I will bring it over to you.
Yeah, thank you. So let me just make one thing clear. So we have shown you noxDB as the central star of this presentation. Niels has shown you some IceBreak stuff where he uses noxDB, or actually it was part of noxDB. I showed you the DevOps tooling that we use to move those objects around, also relying on noxDB. So to make sure that you understand it, that noxDB is actually a standalone application that doesn't require any of the other things, right? So you can just grab that thing and start working with JSON in your RPG with all the things that Niels showed you, to convert SQL into JSON, and all those goodies are actually part of that of this standalone application. All right. Okay. So then lastly, where are we? Yeah, use cases for noxDB. How are we on time? We have still a couple of minutes.
Yeah, we're still good for time. We got about 7.5 minutes.
Okay, great. So let me just, and Niels, jump in, please, if you want. So what we do is, of course, web communication, good use case for noxDB. But also a thing that we have done is versioning of data. So imagine TDOMS, it has a lot of complex configurations, right? So where does your file go? Where does your data go? How do we convert the data? So that is part of our configuration. So if you make a change to that, right, it's always a little bit, oops, I hope everything goes well. So what you can do, or what we have done, is say, okay, before we actually hit enter, we are going to take a snapshot of all our configuration files with noxDB. I mean, it's 20 lines of code for all the files that we have, and put it in a XML file. So now we can change the code. If it doesn't work, we just move it back from a JSON into the configuration files. And it also helps us versioning the configuration file. So this was it last week, this was it 6 days ago, etc. So also general configuration settings, right? So if you want to configure your program with JSON, it's very good. So Niels, you have other use cases for it? So they keep popping up, I imagine, right? Oh, they use it in many ways that I didn't even think about.
Yeah, basically is all the times where you have this JSON in, JSON out, and some of the features are a little hidden. Is actually you can also call normal RPG programs and procedures, giving it a JSON in and JSON out wrapper with noxDB. So there's a JSON call program with JSON parameters, and then it returns a JSON as output.
It is not only XML.
No, in this case, it will actually produce JSON in and JSON out. So so that is one of the features you can do, and that is if you are adding the PCML keyword on the control specs, then it allows that. There's some other thing.
Yeah, exactly. Yeah.
There's another thing I will just show you here very quickly. I get this quick question all the time. What about data into and data gen? Is that supported? Yeah, if you're looking at the data into, then we can use it very simple. So here we have a data structure of an array with name, IDs, and countries, and then you can actually just pass a string into the object graph, and then afterwards,
a JSON.
Yeah, that's a JSON, but it also works for XML, by the way. And then you can just say data into, and then all these rows guys here is actually, you can see this is the data structure. It will take all the data from the object graph and put it into the array in the structure here. So that is one of the way to do it.
Yes.
And you can also go the other way around, where you want to generate the data. So here we have a very simple example where you have an array, and I just put some bubble into that array, and then you say data gen, and then you will want to, by having the rows, you can actually put it into the JSON object. So it produces a JSON object from the data structures right away.
Yes. Wow.
So that is one of the questions I get all the time.
Yeah. So are there other questions from our still 85 people that are still online? So please put them in the chat. And otherwise we have some, I have also added some questions to get us started. Let me just get into this. All right, so I also asked you, okay, because we have SQL and you can do SQL into JSON, so you can also use SQL to do JSON. So why is noxDB better, quote, quote, than SQL plus JSON?
Yeah. This is also a typical question, but I would say you need to use the right tool for the right thing. And one of the good thing about doing JSON directly in the database is that it has a possibility to do nested structure directly. And if you want to elaborate on that structure by adding extra data that is not available from SQL, then you can actually just pass that output that is given back from the club directly. So it will also pass the information with noxDB, and then you can use noxDB together with the SQL and JSON features that are in the database. So therefore, sometimes it's if you're looking at some of the projects I'm working on, you will see a combination of the native SQL JSON features together with the features that are in noxDB, because sometimes it's just so much easier to just let noxDB do all the magic. And
Yeah,
sometimes
exactly.
it's for some reasons you have to also handle data a little different. So it's easier to let the database manipulate the data before it comes into the object graph. So
Okay,
there's
so
no.
we have one more question. Mark Plumridge asked, does noxDB have built-in support for managing user access and role-based permissions for database operations? If not,
Yes.
what best practices do you recommend for securing endpoints and enforcing user access control?
Yes. You do it a little different. You say start transaction, and then you do all the magic with object manipulations, and then you commit or roll back. There's a JSON rollback and JSON commit. So therefore you can do this very easily, but you have to start transaction before, otherwise it will be running without commitment control. But you do it on the fly actually. You don't have to compile your code into a specific mode. You simply use.
Is that the question? Was it about user access?
I believe it was about managing user access and role-based permissions for database operations.
Oh yeah, but that is because noxDB is based on top of the DB2. So whatever you do with DB2, it applies to that. So let's say you have RCAG for role access management, then it will be on obeying these rules totally just like any other application would do. So now there's no going under the covers there. This is using. It's actually implemented with SQL CLI, just like the drivers are for Java and so on.
So if you are not authorized, you just get a message from the database, not authorized to read this table.
Yes, exactly, or read this column or update or whatever. So it applies to whatever you have already. Yeah.
And I'd like just to say to everybody, we're at our 1 hour limit, but we are going to still continue with the questions that we have. We have a couple more questions. Olaf Vogelbusch had said, Wim, did you say TDMS can now do and maintain revisions of configurations and sources via noxDB?
Well, yes. So that's coming out in milestone 2. So what happens is we can extract the TDMS definition into JSON using noxDB. It has another advantage, right? So for example, you have a customer and the customer has a very complicated environment. It could be with TDMS, could be with any other product. And you want to know, okay, the user is seeing an error. We don't see the error. It must be something in the configuration. How do we get the customer configuration to our machine, right? That's very difficult because they don't want to save their files. We don't want to go to the printout. So now we've written something to save the definitions into JSON. They send the JSON to us, and then we can import that JSON into our library, and then we have the exact configuration of the customer, and we can replay their issues. That is exactly what is a use case of noxDB that we are also using it.
Okay, we have another question from Juan Antonio Dardan. What about I have to work with HTTP header?
Oh, Yes, that is also a great question. You're not limited to do only JSON. You can actually also query the headers. But typically, when we are talking about microservice architecture, you will have a router, and I didn't show the router code before, but you will have a little piece of code in front of this that is doing the parsing of the JSON and serializing. So if you're talking about JSON Web Tokens, there is actually in my repo there, I put also an example of how you implement JSON Web Tokens, where it actually goes to the HTTP header and get the buried token out and pass that, because that is also JSON. So it's passing the JSON Web Token with noxDB and see if the token is valid and so on.
But if you're working with IceBreak, you can also add header fields, right? And get header fields also from there. So noxDB in essence it does not know anything about HTTP. It is in combination with Apache or IceBreak that you are worrying about that. But otherwise, noxDB, correct me if I'm wrong, is only concerned about JSON and XML.
Yep.
All right.
Okay.
Other questions?
That's all the questions I have so far. Does anybody else have any other questions? Here we go. Here's another question by Marius Leroy. Hopefully I didn't butcher your name too bad. Sorry. Any professional commercial support available for noxDB IceBreak open source? To Niels.
Yeah. The way we're doing this is the only way you can get 24-hour support on noxDB is by purchasing IceBreak, because IceBreak carries around with the noxDB, and the version we have of noxDB has run through a lot of extra tests than the version you just see on the internet. So we are pulling this from time to time when we have some stuff we really want to put into IceBreak, and therefore the IceBreak is carrying the license fee and the service around it. So this is a way you get full support for both IceBreak with Elastic, noxDB, and Innovator as well.
We have another question from Mark Plumridge. When invoking the REST API via Postman using base 64 encoding for the user credentials, for example, how does noxDB handle user access controller? Again, is there any built-in support for role-based authentication? Or do we need to invoke our own mechanism for role-based permissions for API endpoints?
Okay, yeah, gotcha. Again, as Wim said, when we talk about noxDB out of the box, there's no HTTP whatever built into that. So that the question actually applies to the IceBreak or the Elastic framework, and there you have the 100% possibility to handle base 64. There is APIs to drill out this base 64, parse it into strings, and actually taking the JSON part out of that. But that is a courtesy functions that are available in Elastic and IceBreak.
And also in IBM I believe we have also.
Oh yeah.
Some functions. Also, yeah.
There's another question here, if there's a binary version of noxDB available, and there are actually. If you're looking at the repo, there is, if you click on the release, there is actually a release of it. But you should be aware that noxDB comes in two versions. It comes in a IPsedic version, and it comes into a version of UTF-8. So depending on what you are pulling, it's actually either the noxDB version for IPsedic or UTF-8. And if you're looking at the release version, it's only the UTF-8 version we have put out there. But there's another way to skin the cat. When we are building IceBreak, we also pushes the binary, the save file for that to system methods web page, and I can put a link to where that is. You will see that is quite old, these
Yeah, quite
assets,
old.
because we are leaving that because it's not natural for the build process right now to actually make one of the blobs on GitHub.
Mhm.
So therefore, it is on an FTP side, and we are working on to get it into the blobs again. But we also in the process of changing some of our DevOps systems here.
Yeah. But
So,
the best bet is just to do this, right? Be modern, execute these commands, and then you will have a noxDB library automatically created for you, and you can just start coding.
Yes.
And if you still have issues, give us a call. We will see how we can help you.
Yeah, do you have a
All
slide
right.
with, I thought there was a last slide, Wim.
Yeah, last slide. Let's see. Where is my press? It's here, F11, I guess.
So thank you. Perfect.
Thank you. Thank you, slide. Yeah.
Okay.
And there's also some links here for Remain Software and System and Method. So, oh, it will not go back. But anyway, yeah, so we're done.
So we'll be sharing that with everyone.
Yep.
Okay,
Right.
thank you
presentation will
everyone
be
for
out there.
attending. We really appreciate the folks that stuck around for all the Q&A session, and we'll be in touch with you with the recording. Thanks again.
All right. Thanks, Niels. Thanks, Kirk.
Thanks, Niels. Thanks, Wim.
Thank-
Bye-bye, everyone.
Bye-bye.
Thanks, everybody.
Bye-bye.
Bye now.